Okay, so welcome to today's lecture on Arduino IDE and its uses and all the kinds of sensor that you will be needing in your projects throughout this course. Okay, so let's get started. This is an Arduino. Okay, this is a microcontroller which will allow you to control the functions of all the sensors that I have laid out here. Then you will need a cable like this to connect to an Arduino. After you have connected, you will need to be able to program it. So to program it, you will need a software called Arduino IDE. In the Arduino, like first I'll tell you how to download Arduino IDE. Okay, so I'll share my screen first. Here you have to search download Arduino IDE. Here in downloads, see, you can download from here or from here itself. As I already downloaded, it says download, thank you. Okay, otherwise I have made a document for you from where you can get to do what to do and what not to do. Okay, so you can use that also. Wait, I'll show you. Just a second. So this is it. Okay, so now this is the guide for you. You can download Arduino IDE from here, installing libraries, learn how to, everything you can see here. So now let's get started on how to program an Arduino. Given that you have already downloaded the Arduino IDE, we will start Arduino IDE. Okay, Arduino IDE has started, but like now I'll tell you. First of all, see which board we are using. Arduino, right? You need to go here and select Arduino Uno. Okay, here we are using an Arduino Uno, so you need to go and select here as Arduino Uno. Okay, after that any kind of library that I am going to be downloading is from here, or otherwise from some web which I will put into a zip which will be a zip folder which I will download and paste it in the libraries folder of Arduino. Okay, I'll take you step by step through everything. Okay, so the first sensor that I'll be guiding you through will be a TDS sensor. Okay, so what a TDS sensor does is this TDS sensor, I'll show you. See, this is a TDS sensor. Okay, this is an analog TDS sensor. This is the chip that helps us measure this analog reading that we are getting from this. What a TDS sensor is, it helps us tell what is the, let's say, ionic concentration in a solution. Let's say if it's saline, there's more salt in it, more dissolved salt or not. Based on that, it tells us the quality of the water in terms of ppm. 300 to 400 normally is good, below or more is considered bad. So this will help us determine the quality of water in sense of TDS. Okay, so first let's see how to use it. First of all, we need to first know the connections. As this is a red color, let's first get our connections right. Red colors mean positive, brown, black means negative. Okay, and this orange normally means signal pin. So we'll connect this 5 volt to 5 volt pin on our Arduino Uno. Okay, I have connected this, and this one I am connecting to ground. By the way, the wires that I am using are called jumper wires. One is male to male, these are female to female jumpers. There are different kind of jumpers. This is male to male jumper, like both are pointy, and one is female, this one is male to female. Okay, so using all this sensor, we are going to finally, after learning this kind of sensor, we are going to make a project that will allow us to do more and more things, and we'll also be learning the application of AI that you can do while coding. Okay, so now where does this signal pin go? This signal pin will go according to what the code says. Okay, so I am giving out the example codes that you will be using so that you won't have to brainstorm or something and find somewhere else. I will be giving you everything here. Okay, so this is the signal pin. Now I will show you the code. The signal pin says connect it to the A1 pin. Okay, it's defined TDS sensor pin is A1. A1 means analog signal pin 1. It will do analog read and give us the ppm value in terms of ppm. Okay, the prerequisites for this is that you should know basic coding for that is needed for Arduino. If even if you don't know, it's okay, you can learn it. I will give one link at the end of this document that I'll be sharing with you. There it will be a whole lecture of around 50 means some videos that you will be able to learn after watching them. Okay, you can then do this type of coding easily, and even if you don't know, you can still do it. I'll tell you how, but it's better to always learn it after, then you can use the method that I'll tell you. Okay, so see, here we are calling this library called gravity TDS. Okay, this is TDS sensor. Whatever we are going pointing, see, this is the A1 pin. We are defining what pin we have to connect. We are, see, here we are giving flow temperature. We are considering that the temperature of the water is 25. Okay, and based on that we are calculating our what do you say, based on the temperature and analog value, we are calculating the TDS value in terms of ppm. Okay, so let us copy this code. If you just read the comments here, you will be able to understand which line is doing what. But if you don't know, then it's still okay, you can do it. I will tell you. Okay, so let's go to our Arduino IDE. Here I will just paste the code, Control V. But first of all, we should know where this library came from. So what I will be doing for you is, see, look here, I will give you links to download the TDS library. So here what you have to do, just click on this. Okay, here you will directly be downloading this library. You just have to press on OK, then it will get downloaded. Then you just have to move to the folder. You have to go to File Explorer, File Explorer. Here in File Explorer, in downloads, you'll find this. You just need to extract this folder. Okay, extract all. But that extracting location you have to set. See, browse, you have to go to documents, then you have to go to Arduino, then you have to go inside libraries. Here only you have to select folder and extract it. Okay, after extracting, a library like this Arduino temperature control library will be there for you. Okay, so let's close this thing. As I have shown you how to download it. Now let us move back to our Arduino IDE. Okay, this is okay, we are here, gravity TDS. So let's upload this code and see what happens. Or otherwise, wait, I have an idea for you guys. Like, see, I have created a library for you here. All the libraries that you will be needing from now on here throughout this whole sensor introduction to the end, all of them will be available. Okay, so what you have to do, just click on this. Okay, then go here, download zip. Okay, after you have downloaded, okay, then go, then show in folder. After that, extract all, and just the same, browse, go to documents, go to Arduino IDE, go to libraries, and just select this folder and paste it. Okay, after that all your libraries will be there. You don't have to do anything. Only one library that you will have to add will be U8G2 by Oliver. This is the only library that you have to download. Just click on the install and it will be installed. Okay, library manager, it's right here. You have to click on this to get your libraries. Now all your setup for the libraries is done. Okay, if you want to know how specifically I am downloading libraries, I have given the links on how to download and stuff right there. and I also showed you the zip GitHub version on how to download the zip file and extract it. And on this Arduino IDE, you just have to search it here and install it. But don't forget U8G2 by Oliver. This is for our display that you will be using. Okay, so now let's get to our TDS sensor and this example code that we were using. So let's first upload this code. Okay, done compiling. Now it's uploading. Okay, it's uploaded now. So how do we see what's the value? At the right top corner, see, you can say serial monitor here. You just have to click on it and you'll be able to see values. But first, okay, now it's saying 0 ppm, it's printing question mark and something. Let's say it's printing the baud rate. Baud rate is the rate at which a laptop and that microcontroller is communicating. Okay, let's set to it. Okay, seems like this one is what this TDS sensor is set for this baud rate. Okay, so now let's have some water to check if this TDS sensor is working or not. Okay, here I have a cup of water. I'll just dip this thing inside it. Okay, I am getting around 300, 280, 282 ppm. It seems like this is good quality water. And let's say if you don't know what is good quality water, what is not, nothing. You just have to see what value of ppm sensor TDS value means good quality water. You can just search assist. See, level between 300 to 500 ppm. Okay, which levels above 500 ppm can affect taste and may indicate potential contaminants. Okay, so in this way now you know 300 is a good thing. Okay, this is done. We know how to use a TDS sensor. But do you know, we have set the temperature as 25 degree Celsius by ourselves only. But we don't know what is the actual temperature. So it is necessary that we use a temperature sensor to get the real time temperature that is being calculated from here. So here, right here, we have our temperature sensor. Okay, so wait. See, here we have our temperature sensor. This is the TDS sensor that I have put into the water. Okay, and this is our temperature sensor. To use this temperature sensor, see, this is ground, this is power positive, and this is signal. The thing you have to do is, see, this is a breadboard and I have added a 4.7 kilo ohm resistor in this. You have to connect both of them, the positive terminal and the signal terminal. Between these two terminals you have to add this resistor. Okay, that is your first task. Okay, let's add it properly. After this is done, you have to add this black to the ground. Now this is done. Okay, let's go to our guidebook. Okay, so here in our guidebook, see, this sensor is called DS18B20. Okay, this is the example code that we'll be using, and see, here it shows us it should be on pin number 7, this sensor. Okay, so let's take a male to male, let's take a male to female jumper, because the, what do I call them, the female headers on this, if you put these male headers inside them, it gets loose quite easily, while compared to the male ones and female, their joint is quite good. So you just have to get this signal pin from this breadboard. Okay, wait, I'm not showing you the hand cam, na? Wait, okay, here you go, this is the hand cam. Okay, so here you have to do this, then get your signal pin and connect it to pin number 7, that is D7. Okay, now it is connected to D7. Okay, now after it's connected to D7, what we need to do, our temperature sensor is connected, everything is there, resistor of 4.7 kilo ohms is between them. So now let's copy our example code. So this is the example code. Copied it, go here, Control A, Control V. Okay, we pasted it. Okay, gravity, Dallas temperature, TDS sensor, everything is there. Okay. As we have gotten our like temperature sensor hooked up, so we can just put this thing inside the water. As it's waterproof, you don't need to care much about it getting into water. Now let's upload this code. Uploading, the code is in middle of getting uploaded. But now let's switch to our code. Now I'm seeing serial monitor. I don't see that. Why is the temperature like this? Okay, let's check our wiring again. Okay, everything is connected. Okay, I forgot to add the power pins and ground pin from the board to here. Let's do that first. This thing goes to 5 volt and this thing goes to ground. Okay, now all the connections are made. Now let's check again. Let's switch to the display. Okay, now see, it's working. With real-time temperature, we are getting actual ppm of the water. So now in this way, you got the temperature of water and you also got the quality of water, means whether it's too salty or it's drinkable or not, or it's okay. So now that we have displayed this thing in serial monitor, we should be able to display it on a LCD display as well. Okay, this is an LCD display and it works on an protocol called I2C. The I2C protocol is being used because see, here there are so many pins. To convert this into just 4 pins, we will use this protocol. To study in detail about it, you will have to search about it. Okay, so let's use this. I have already got the wires connected. This is ground and this is power pin. First connect them accordingly on the LCD display. Okay, then there's a pin called SDA and SCL. SDA on Arduino is analog pin 4 and SCL is analog pin 5. Okay, let's get them connected. Okay, it's connected. Okay, now it's connected. Let's search for our example code. Okay, you didn't see the cam. See, here it is. Okay, it's blinking badly right now. Wait, it's just because of the wiring issue. Now it's okay. Okay, now I have connected them properly. Now what we'll do is we'll go to our guide. Okay, in our guide we will find the I2C scanner code. Okay, we'll copy this because see, these LCD displays, as they work on I2C, these I2C things have their own addresses. So to check what address this display exists, we have to do this. In serial monitor, it will give us the address of that. Okay, so now let's check the address. Going to serial monitor, changing the baud rate 115200. Okay, I2C device at 027. Okay, now we know the address. This is, if you would like to see the code, this is the speed at which they will communicate. Then it is the print statement. The wire begins, start I2C. Okay, then here we are running a loop. Okay, addresses ranges from 1 to 127, so it is checking the address from 1 to 126. Okay, So then when it finds the address, it will print that value. This is that code. Now let's go to our example code to display. We'll display hello world on I2C display, I2C LCD display. Okay, I'm taking this code, going to Arduino IDE again, Control A, Control V. Okay, I pasted it. Now let's first understand what's there in the code. Okay, first we are initializing our liquid crystal I2C LCD display, that it is at address 0x27, 16 columns and 2 rows are there. Then we are initializing LCD, and then we are initializing backlight as well. Then this is our column 1 row 0 hello world, and column 2 row 0, this is an LED. Okay, so let's just print it by uploading the code first. I have uploaded the code, it's in process, code is being uploaded. Okay, now let's check if it works. Let's switch to the hand cam. Okay, now here you can see that there is nothing visible, it is just some kind of light. This is because we haven't calibrated the potentiometer behind it. Okay, let's try calibrating it. Wait, first let me change the position of the Arduino and stuff. So see, it's not visible right now. Let's make it visible by turning this potentiometer when the LCD displays. Okay, see, now it's showing something. Okay, now it's not. Let's adjust it properly so that it should at least show something. Let's try to get rid of this glare. Wait, let's see if it will be visible. Okay, it's still not visible. Okay. Okay, now if you just zoom a bit properly, you will see it is printing hello world. Okay. Okay, it's printing. So our LCD test here is done. Now what we'll do is we'll be printing the values that we are getting from these sensor onto this LCD display. Okay, so now what I'll be doing is, let's say you don't know how to do the coding and stuff, right? You know at least basic syntax and how this code works. So what you can do is go to our documents, copy the code for our temperature sensor with the TDS sensor. We'll copy this code, go on the browser, go to ChatGPT, paste this and go to Arduino IDE, copy this LCD code and then go to ChatGPT again and print this as well. So what I'll do is I'll ask this ChatGPT to combine this code for me. So I'll just tell it what I want. I want the data that was being printed on serial monitor for the TDS and temperature sensor on LCD display instead. I have provided you with the basic codes. Provided you with the basic codes. Okay, see here, I have printed both of them, the codes, and put the prompt. Okay, I'll just send it. It's okay if you have some grammatical mistakes, it can still understand. Okay, now let's see if this code works. Copy code, go to our Arduino IDE, Control A and Control V and upload. Code has been uploaded. Now let's check our LCD display. I can see that it is printing TDS value as 300 and temperature as 24 degrees Celsius. See if you can see it here or otherwise here. Okay, it is printing the temperature value as 24 point some degrees and TDS value as 290, 80, something like that. Okay, so we have successfully used AI to combine these two example codes that I have given you. So just like this, you can think of anything and just get those code, put your idea, and you will get your code. Okay. Uses of our TDS and temperature sensors are done, but now we need something other than our serial monitor to view it. So what we'll do, we'll use this LCD display and print the values on it. Okay, let's get to it. But before that, one thing I'd like to tell you, that even if you are using, let's say, an laptop, and just in case you don't have a laptop, then how will you program? I'll add a link at the end of the description where there is a YouTube guy. He'll teach you how to program this Arduino through your phones. So there's no problem in that. Even if you don't have a laptop, you'll be able to use Arduino. Okay, so now let's get to our I2C display LCD. So we'll go to our, we'll change our hand cam to display capture. Okay, this is our I2C scanner. So what this I2C protocol is, it just is means the main reason it's being used is to convert all these so many number of pins to just 4 pins. Okay, so you can study more in detail about it. So now we'll just be scanning what, see these I2C devices now, they all have their own addresses. That's the reason why we have to scan what is the address, because if it's when we upload things on this and when we want to print something, we have to give their address also. So first we'll be checking their addresses. Let me get my Arduino ID here. Okay, my board, Arduino, everything is selected. Control A, cut. I need to paste this I2C scanner. Arduino ID, go here, paste it. Before that we also need to connect our LCD display. Let's convert to hand cam. So where this LCD display will go, red goes to 5 volt pins. Okay, we have a breadboard also. I'll just put it on breadboard. This goes, or otherwise Arduino is also fine. 5 volts, and this pin goes to ground. So I'll put it into the ground. Okay, it is done now. This, but I don't know where SCL and SDA pin goes. I forgot. So what I can do in such a situation is, I'll just go to our browser, whichever browser you have. Okay, I have this browser, so I'll just go here, and now I'll search Arduino Uno pinout. We'll go to images, and then in images here just find a good pinout. Okay, this one seems okay. Okay, I'll open this photo image. I'll zoom. I want to know where SCL and SDA goes. Okay, here it's shown that SDA goes on A4. Okay, and our SDA is orange color. So this thing goes in analog pin 4 and that goes in A5. Okay, in this way we can get to know which pin goes where also. If you just don't know, just search the pin out and you'll find it. Okay, now we find our I2C display. Now it's connected. Now we need to connect our cable to upload the code. Okay, these things are getting powered on. Yeah, display is getting powered on. Okay, display is powered on. Let's go to our example codes. Copy this, go in Arduino IDE. Okay, I forgot I had already pasted this. Okay, then I just need to upload this code. Let's open the serial monitor and let's see if it shows any. Okay, it's showing no I2C devices found. Let's check why. It says SDA orange pin goes in A4. Put it in A4. This thing also. SCL goes in A5. I put it in A5. VCC and ground are also correct. Okay. Okay. Nothing, it was just a starting error. Now it's telling I2C device at 0 cross 27. Okay, so now what we have to do, now we know address is 0 cross 27. Now we can just go forward, use our example code and check what happens. See, here we have declared the address. This address is really important when using I2C devices. Now we'll go to Arduino IDE, Control A, Control V, upload this code. Now let's check if the display works. See, if you are able to see zoom properly, you will see it is printing. Okay, hello world. This is an LCD screen test, right? So our screen test is done. Let's see what's happening in code. Here we are including the library for this I2C display, wire.h, liquid crystal. We are declaring the address, number of rows and columns in our display, initializing our LCD, turning on the backlight. Then we are setting column 1 and row 0 for our print of hello world. Then we are adding a delay, then we are clearing the delay again. Then here in the column 2 row 0 we are adding this is an LCD, and column 2 row 1 screen test. So at the same time it will show this is an LCD screen test. There is no delay between them because we want them to be printed at the same time. It's in different rows after all. LCD clear. This is simple code. Now we have uploaded, everything is done. Now what we wanted to do was use our this code, that is TDS plus temperature sensor. Okay, and display it on Arduino and display it on this LCD display. But let's say you don't know much about how to do coding and you just want basic syntax. Okay, so what here you will be able to do is, see, I'll print this code, I'll go to our Arduino IDE, I'll copy our example code and print that as well, and I'll say I want to display TDS data on I2C display. I have provided you with the example codes. Bas, even if you tell this, it's enough, it will do it for you. It's almost done. Okay, done now. Copy this code, go to your Arduino IDE, paste it, and now let's see if it works. The code has been uploaded I'll first reset the Arduino Uno. Let's check now. I'll switch to hand cam. Okay, let's switch to our hand cam. Okay, it is printing some values, but it's printing minus 107, minus 127, something like that. Why is it so? Let's try debugging. Okay, I don't see any signal pin connected to the Arduino. Okay, that's the mistake. I forgot to connect the pin number 7 with the Arduino. Okay, now let's try again after doing this. Let's see if it works. I'm resetting it. Now let's check what happens. TDS meter ready. Okay, let's see. It is printing values as 228 ppm and 23.7 degrees Celsius. Okay, so it seems to be working now, this LCD display. Try if you can see these values. Okay, so it's working now. So in this way we can use the AI to do the coding for us. We just need to present it with the ideas. Okay, now let's get to our next sensor, that is our turbidity sensor. Okay, so this is the turbidity sensor. There is just one slight problem with the turbidity sensor that I have, is that I just overused it once and just rotated the potentiometer too much, so it doesn't seem to be working now properly. But I will show you how to connect it and how its basic code will work. Okay, so now let's get to our turbidity sensor. Hand cam off. Our guide. Here's the guide. It's here. See here, what I have given you is like I have given you a code directly to display the values on LCD display. If you want, you can just take out the LCD thing and just print it on serial monitor. So now I'll take this code, go to Arduino IDE, Control A, Control V, upload this code. Okay, uploading, upload done. Now we have our code. Okay, let's make the connections. We will need some female to male connectors. Okay, it is right here. We will connect them accordingly. Left one is ground, right one is volts, that is our positive terminal, and middle one is the signal one. Okay, now as we know, on our breadboard we are getting our 5 volts and ground anyway, so we will just connect this thing right here. As you can see, the LED has turned on, it means it's working. And according to the code, let's see what our code says. It says sensor pin goes to A0, so we'll connect it to analog pin 0. Okay, now this is done. So code is uploaded. Now let's check if it will print any kind of values. Okay, of course it won't, because we are displaying it on the LCD. So now what's happening here is, see, I am getting turbidity as cloudy, clear, and some random values. It's just because that this sensor is broken now, it doesn't work. But as I have given you the basic code, I'll explain it to you and how to change the values accordingly. So see, here is the code. What we are doing here is, just like how we initialize LCD display, we are initializing it. We are declaring our sensor pin, the same process as we did declaring the LCD, means initializing backlight on, etc, etc, including libraries. Now let's get to here. what we are doing for the sensor value is, as we have connected it to the analog pin, we are doing analog read on that pin. Okay, so using analog read we are getting what the values. Okay, then we are getting values. So what we are doing in this line is we are mapping the values of this 0 to 640 to 0 to 100. It just means the values from 0 to 640 are being converted to 0 to 100. Okay, like you can just think of it as like if like 4 is 2 and 1 is 0, something like that. Okay, so just it's just mapping, normal mapping. Okay, then LCD clear, same thing, same, just print values. What now, the thing now where you need to change is right here. Okay, see what it does is, if turbidity is less than 20, print clear, else print cloudy. Okay, what it's doing is, whenever the value of turbidity is less than 20, it will print clear, otherwise it will print cloudy. So what you have to do is, when you use your sensor, it will give some value for some kind of clean water. Let's say whatever value is given, let's say I'll say it is giving 40 value for your clean water, constantly 40, 39, 38. So what you have to do, you just need to change the conditions here to 40 and have it clear, else cloudy. Okay, that's all. Now we have uploaded the code, we have seen it's printing. So now what we'll do is, we'll be printing the values of these both sensors and this TDS sensor, means turbidity sensor, also on the LCD display. So I have given you all the example codes for the TDS plus temperature on LCD, TDS temperature plus turbidity on LCD. Okay, this you can try it on your own. And now I'll just get to the another sensor, because I'll be introducing you to this OLED display as well, because there's not that much space on that what do you call this, LCD display. So in this OLED display we'll be able to display more and more values, because I won't be just adding these three sensors. I'm going to be adding this smoke sensor also, and this DHT11, that is our humidity and temperature sensor. So now let's get to our humidity sensor. Okay, this what is humidity sensor works on is, just it has a material inside of it which changes its property based on the humidity, heat, temperature, etc., and calculates relative values. Okay, now I'll copy this code, go to Arduino IDE, upload this code, done. Now let's get to our connections we need to make. So this is our DHT11. Okay, I'll be connecting this to power and ground on our breadboard. Okay, okay, connected it. Now I need this thing to go on the signal pin. So according to the code, let's see what our signal pin is. Signal pin is pin number 3. So let's go to pin number 3. We have gotten to pin number 3. Okay, I have uploaded the code. Let's see what it will print. Baud rate I had set to 9600. I am setting baud rate to 9600 and just checking what will happen. Okay, it is printing it properly. The humidity and temperature. Humidity is around 71%, temperature is around 29.3 degrees Celsius. Okay, we have done the basic thing. Now let's see what is in the code. By the way, all the libraries that we have here I have added in the GitHub zip file that you have to download. You will get all your libraries right there. Otherwise I have added separately also how you can download single libraries. Okay, so this is just defining the pin, then DHT library including setting the communication speed, printing values, then this is the loop. See what this will does is, this will just help us wait between the measurements. See, it's printing after some time. Now we are setting this time here. Okay, Then we are setting the parameter like values, declaring them float h, float t, float f. Okay, then this is the conditions, fail to read from DHT sensor. Then we are setting this also, compute heat index. These functions are already there in library, you don't need to care about them, you just need to call them. Okay, and this is just printing the values that we are getting. Okay, it's simple code. So this is our DHT11 humidity and temperature sensor. Now let's get to our next sensor. That will be this smoke sensor. Okay, it will detect any kind of smoke. Okay, wait, let me show you it in hand cam. Okay, see right here, this is our smoke sensor and this is called MQ135. I am using the one by Waveshare. Let's go. Red one goes to VCC and black is for ground. I'll just get them connected first on the Arduino itself. As I have more pins, I don't need to do it on breadboard, but I'm just doing it on breadboard for your convenience, because if you don't get a like Arduino Uno that has this many pins, you just have to have a breadboard, connect the positive and negative, and you'll have many pins just like that. Okay, now it's getting problematic for me to add. Okay, what I'll do, I'll just remove this LCD display because I won't be using it. Because I want to use this OLED display, right? So it's not needed anyway. Now I will get this connected here. I'm connecting it to 5 volt only, 5 volt and ground. See, LED lights up. It means it's working. Okay, let me shift these things forward a bit for you. Okay. Now, what is this D out? It's our digital pin. Okay, we don't means. Okay, first let's go where according to code we need to know now. Let's go to our example code and see what the code says and where it wants us to connect it. Everything is given in the coding. Okay, this sensor I have added at the end. See, gas digital input. Okay, this is where we are doing it. So it goes to pin number 2. 0, 1, 2, that is the third pin. Now this is A0, that is analog pin 0. Am I using analog pin 0 for something? Yes, I am. So what I'll do, I'll just change this analog pin 0 to 2, because the analog pin 0 is being used by turbidity sensor. Okay, now I am using A2. Now you have to wait for this thing to heat up before you can use it. Okay. I'll copy this code. Go to Arduino IDE, Control A, Control V, upload this code. Okay. Let me bring a matchbox. We'll try detecting smoke using that. Okay, let's see what values it's printing. We need to set to baud rate according to what the code says. Okay, gas not leak, it's printing gas not leak. Okay, got it. Okay, I think it's done heating up. Now we can try testing it. Okay, so this is the matchstick. What I'll do is, see, you just see the top window. I'll just show the serial monitor if it will print gas leak or not. Okay, see, I have added. Now let's see if it will print gas leak based on the smoke. Doesn't seem to be producing that much smoke. Okay, it's not producing that much smoke. We need to try using something else. Okay, matchstick didn't work. Okay, maybe an essence stick will work. Any kind of agarbattis you can use that produces lots of smoke. But that is not the only thing this sensor does. It can detect smoke, alcohol, LPG, CO2, something like that. Means it has many uses. So see, this thing is lighter. It has LPG mixes, propane. So what we can do is I'll just light it up just a bit to check if it shows anything else. Okay, I'm lighting it up. Okay, it says gas leak. It means this thing is working. See, okay, there's a gas leak. So this is how a gas sensor works. When you are doing the experimentation, handle it with care. Better to use an incense stick. So what I'll show you what all these sensors can be used together for. So now this is the final thing, that is our LCD display. Oh, by the way, this is not the final thing. I have a homework for you also. See, this is a pH sensor I have right here. Okay, using this you can measure the kind of acidic concentration and other thing that a solution might have. This is not a necessary thing, but if you want you can try using it. Okay, this one is just a bit more on the expensive side, that's why I haven't covered it, and a bit difficult to use as well, but if you want you can try. Now we are here. Now we need to go to our OLED display. So what we'll do is we'll print all this value on our OLED display. Let's go to hand cam. See, this right here is the OLED display. It is the same I2C, but it just requires a different library, that is U82G, U28G, something like that. UG82, U8G2. Okay, U8G2 it is. So if you use just that library, I've already given it in the, what do I say that, in the GitHub, so you can just copy it from there. Otherwise I have given the description links also, okay, how to download. Okay, so now let's go to our document. Let's see how to first use an OLED display. See, here, right here is our OLED display. If you don't find the library in that zip file, you can just search U8G2 on your library manager and you'll find it. I'm copying this code, going in Arduino IDE, Control A, Control V. I uploaded the code. Okay, till that time I'll just make the connections. I will need 4 male to female, or female to female will also work. No, I need male to female. Okay, I got 4 male to female. Okay, code is uploaded and now I can show you hand cam. I'll just get this pin here and connected. VCC and ground are beside each other. It's a good thing, we can just directly connect them side by side just like this. This is also I2C, it has its own address, but because of the library that we are using, we don't need to care much about it. We'll go here, connect it on the breadboard where everyone is connected. Okay, now what we need, we just need to connect this to SCL and SDA that we just found out. SDA is A4, SDA here is yellow colored, so we will just put yellow color in A4 and orange in A5. Okay, here it is. Now let's reset the code, reset the Arduino and see if this thing starts. Okay, see, it started. it says hello Arduino exclamatory mark, and there's a question comma in between. I don't know if you can see it, but there's something being printed. Okay, it's printing hello Arduino. Now what I need to do is get all the values of this sensor on that OLED display. So now I'll go to my this thing. See, here I have gone step by step: temperature, TDS plus turbidity on OLED, then temperature plus TDS, turbidity plus smoke on OLED, then here temperature, TDS, turbidity, smoke plus humidity sensor on OLED. Okay, all these things you can easily do. First of all, you can write the code on by your own. That's the best thing. Okay, now if you already know everything, let's say you have mastered everything, you know how to write, to save time you can use AI, or otherwise you don't have that much time to learn the coding fully, you can just learn basic syntax. So you can just copy all these example codes that I gave you, and step by step, one at a time, just combine them, test them, combine them, test them, combine them, and you can come like this. Then the code has like more chances of working. So now I'll just directly test the final code here. Go to our Arduino IDE, Control A, Control V, upload this code. Compiling the sketch. Done uploading. See, this is the values that it will be printing: turbidity, DHT, every values. I'll just show you first here. Let me make this bigger. See, it is printing temperature, TDS, turbidity. What's this? This is the smoke sensor. If it's printing OK, it means it's alright, nothing has been detected. If smoke is detected, it will print something. Okay, and then this is the DHT 11 values. Okay. Okay, I was just wondering why this temperature sensor was not working. The reason is that it got removed from the breadboard. Okay, let's take this wire. Okay. Now let's see if it starts working. While the connections are made properly, I'll start the code again. It's working now. See, 24.2 degrees Celsius, 224 ppm, turbidity. See, turbidity will most probably be wrong. For me, there are high chances that it can be wrong. Okay, because it's printing 50% properly constantly. Okay, 49%, 50%. So what I can do here, from 50% turbidity, I can just conclude that when it's around 50%, it means the water is clear for me. Okay, for others it might be something else. Okay, so then it prints okay, it means no smoke detected. Let's try bringing some kind of smoke, that is our LPG, near it, and let's see if the value changes. We need to check if our serial monitor is working. See, it prints detected. Okay, it's working. Turbidity sensor will also work. You just don't adjust it by your own. Just check if it works first and then try adjusting its potentiometer. You will need a screwdriver for that. Everything else has been printed. Now for the final thing. Let's see if all of these things are being displayed on our OLED. Nice. All the things are being displayed just like how it's being shown in the serial monitor. Temperature first, then TDS, then turbidity, then DHT11, temperature, humidity. Nice, it's working. So in this way we have learned basic sensor usage, how to use Arduino IDE, how to use AI to code, whether we can code on a laptop and mobile phone as well. You don't need a laptop to code. Then what else we have learned? We just learned displaying everything, displaying all this value. So now what to do with this? We can try making an example project with it. That's the final goal of our this guide, okay, because you also need to make a project. So after getting all this sensor, what I thought of making was this ship. Okay, so what I'll do with this is I'll add all these sensors to this ship and make it a aquarium water monitoring system. So what in here it will do, I'll add the display here, so it will print all the values that here, so we can just let it float on a fish pot. Let's say you have a big fish pot, or let's say you don't, let's just assume you have it. Okay, so you can just keep it there and you will know what's the water quality, what's the everything, so you can just keep your fishes healthy. That's all. And for the smoke, what smoke sensor will do, let's say there's just something oxygen, something is burning inside, let's say your motor or something started burning, the smoke will get accumulated and you will know. Means smoke sensor can be used in many cases. This is just one of the example where I'm using it here. So this is just ship. But there's more and more things you can make. If you learn just this one thing, you will learn more things. See, here what I have is, I'm using an Arduino only, but it's just a smaller version called Arduino Nano. Here I have a Hall effect sensor. I won't be telling you what it is. If you are curious, you can just search about it. So what it does is, it will help you measure the magnetic field strength of a magnet, and it will also tell you which one is the north pole and which one is the south pole. See, I'll turn it on for you. See, I'm using a 9-volt battery here, okay, and just connected it to the V in pin, and this is a switch. It's your choice whether you want to use it or not. See, I turn it on. Okay, that OLED display just turned on. I always prefer to use these OLED displays because they are much more better, have more space and look good as compared to it. See, if I bring this magnet near, it will increase and decrease the. So you can make many projects just like this. This is just the one really small example. If you want to do something, you can just do it by learning this Arduino IDE, Arduino and everything, microcontrollers. So now I'll just show you the finished version of this and let's see how it works. Okay, so I've completed this. Now this is how it will look like. See, this is a 9-volt battery. I've connected it to a DC jack. You don't need to do this. You can just directly connect these wires, that is red in V in and black one in ground. But as I had this, I just used this. Okay, so what I need to do is just power it on and check if it works. Okay, I gave the power. Now let's check. Okay, it's not working. Let's see why. I'll try changing the battery to see if the voltage got reduced. Okay, now I'll use this one. Okay, let's reset it and see if it will work. It's still not working. Okay, then I'll also have to follow the same method, I think, that is giving power through V in itself, because my jack is not working. Okay, see, this is the thing. We'll use the new battery itself. I'll put it here and just connect this in the V in pin. the ground plane. Okay, after checking for quite some time, I found out that see, it is powering this thing. Okay, no issue. You can see the lights lighting up, but it's not able to light this up. It means it's just a issue in the Arduino. So you can just make it independent using this. Otherwise, this as well. I'll show you how. Connect this in V-in pin. See, you just need to connect this in V-in. Red one goes in V-in and this one goes in ground. See, it's powered on now, just like that. You can make it independent. As this Arduino is not working anymore, I'll just connect a wire to it. Means wire, I mean the cable for uploading itself. I'll power it from our laptop. Okay, so this is done. So see, I'll tell you how this model works first. So what is this, these two things, they will be lying in water somewhere, wherever you want. Okay, they just need to be dropped down from this ship. Okay, this turbidity sensor will be on this side. Wait, I can show it to you now. I'll just show it to you. See, this is the turbidity sensor. It will float with this shape. All the sensors that should stay waterproof are above. This is Arduino, and this is where it will be printing. This is where the smoke sensor is. So this is our working aquarium monitoring system. If you would have known how to use an ESP32, you could wirelessly send this to your mobile as well. That is your choice if you want to learn it. See, now I'll show you. It detects. I'll try again. It detects. Okay, so everything is working. So this is our home monitoring aquarium. No, not home monitoring. Aquarium monitoring system. You can make cool projects just like this. That's all. If there's any query, I will also provide a Gmail where you can ask doubts and stuff if you want to. And this is it for the videos.